All right. So how many of y'all read chapter 2? Anyone? One person? How'd it go?
It was a lot easier than the first chapter.
Okay, all right.
They had a lot more examples on how to think of things.
Okay.
So it helped out a lot.
So chapter 2, yeah, hopefully this will help clarify a lot of how to work with object-oriented, I guess, programming in general. I'm going to go through their slides real fast just to make sure it's clear what's going on and probably give you a couple more examples. All right, how to think in terms of objects. Yeah, you need to know the difference between the interface and implementation, thinking abstractly and giving user a minimal interface. So what's the difference between interface and implementation?
Interface describes how you interact with it.
Yeah, okay.
And implementation is actually setting it up. I don't know if that makes sense.
That makes some sense. So your interface is what you're providing to users of your object. So if you're you can think of it as server client in a way. If you're a server, what are you allowing people to access to on the server? Implementation is how you implement or how you complete what you provided through the interface, or what you say you're going to provide through the interface. Let's see what the book's definitions. When designing a class, the user needs to know what the user does, vital importance, data. Okay, that's just the interface. Thank you. So the services presented to the end user compose the interface. And what you want to do is you really want to minimize the interface while still allowing the user as many capabilities or functionality as possible. So make sure the interface only has what the user needs to know. The implementation are the details, and they're usually hidden from the user, but it's the details of how you actually complete what the interface is. All right. Let me jump over to what example did they give in the book? Do you remember one that you liked, or otherwise we can come up with a brand new one?
Yeah, no, I didn't write any notes about.
Okay. We'll do a bank account example. So, you're inside a bank account. What do you want? Do you need to? All right, let's see how to do this. Hopefully, you all have bank accounts. If not, well, think about having one. If you have a bank account, what do you want to do with it? Deposit money. You want to be able to deposit. Okay. So, public Boolean deposit and some dollar amount, right? Okay. Return true for now. What else do you want to be able to do? Withdraw, okay. Withdraw. And some amount as well, right? Now we'll just say false for now. You can deposit all you want, but you can't withdraw. All right. Anything else?
Check the balance.
Check the balance. Okay, here we go. Call it public double get balance. You have no money. We'll get to that in a moment. It's good when you're stubbing out the functionality, you just give default values that will at least work.
It's even better when it's true to life.
Anything else?
Transfer money.
Want to be able to transfer money to another account, right? Okay. How would you do that? Could you do a transfer with those functions right there?
Well, you need the account number of the person you're trying to transfer to.
Okay. Well, if this is your bank account, you also want to be able to get your account number, right? Right. Okay. So let's go ahead and public. We'll just say it's an int get account number. So if you have the account number, all right, be able to get the account number. Okay. But if you have a transfer and you have two bank account objects, Can you do that transfer with deposit and withdraw? Well, you're withdrawing from one, depositing to another, correct? Right. So the transfer could be implemented with just deposit and withdrawal. So you probably don't want to make that a separate function because you already have the capabilities for that. But that's a good example. All right. And we'll just say your bank account number is -1, aka we don't know. All right, let's just stick with this for now. Okay. If we're doing a very simple implementation of this, we could just have inside of the bank account a private double amount, maybe another private int balance, M balance. Now I put the letter M first, which just symbolizes member, and that just makes things clearer for me. And y'all can't see in the back, can y'all?
Not too well.
How about now? We'll all program in the dark.
You wouldn't make the account number private?
I would make the account number private as well, because you don't want people to just changing the account number for no reason. So that's private. What we got? Int M account number. Okay. Now we do need to create a constructor for this class. What is special about the constructor? I think we covered constructors. So the constructor is called when your function, your class, or your object, I'm sorry. Your constructor is called when the object is created. So when this object is created, what do we need to know? If you're creating a bank account, what are some pieces of information that you need?
You need to know what a bank account is.
Right. And I just realized amount and balance are the same thing. I don't know why I made them separate. So we're going to get rid of amount. I don't know why I made it separate. I think I was just...
Maybe you're depositing a certain amount. You're not depositing your balance.
Right, but you're only going to affect the balance when you do your deposit and withdrawal. So balance and account number are the two things that are members. So when you're creating the bank account, what does it need to know? It needs to know the initial balance and what the account number is. All right. So we're going to go in here and go double initial balance, and then we'll do int account number, and then we'll just set them. M balance equals initial balance. Whoa. And then, did I misspell that? Looks like I have an extra I somewhere. There it is. And then the account number is equal to account number. Okay. All right.
Both of those are spelled wrong, even though
Which one?
both initials are spelled wrong.
As long as you misspell things consistently, it's all that matters. Is that spelled correctly?
Sorry.
Thank you. Spelling. Not programmer's strong suit. All right, so if we want to deposit, what do we need to do? Well, we just can't really deny the deposit too much, so we'll just do balance plus equals amount, and then we'll return true. Okay, that was great. So if we're doing a withdrawal, I'm just going to code this out. If M balance is less than the amount they want, we're going to return false because you don't have enough money. Otherwise, we'll just have balance minus equals the amount, and then return true. And then to get the balance, we'll just return balance, and then account number, and account number. Okay. So what is the interface that we have right now? Yes.
I have a different question.
Sure, go ahead.
So the constructor, what exactly does that do,
So let's write some test code. I'm going to go and create a new Java class. Call it the bank account tester. Public static void main string, capital S, string args. So if I go bank account, I'll just call it, whose bank account should we have? John? Give him John. Equals new bank account, and we'll give him an initial value of 1,000, and his bank account number is 1234. So here's bank account. That's the constructor being called.
so that calls another class.
It calls the constructor of the class.
Okay.
When your object is created, the constructor is called, or a constructor is called. You can have more than one. Let's look at that constructor. There's one major difference between that function. Well, there's actually two major differences between that function and the rest. What are they?
Doesn't have a data type.
Right, it doesn't return a data type. The reason for that is the data type you're returning is an object itself, so you don't need to specify that. The constructor is constructing the object, so it's implicit that it's returning itself. What's the other thing that's unique about that function?
It has parameters.
It has parameters. The other ones have parameters. What's the name of that function?
The same as the class.
The same as the class. So the constructor has to share the same name as the class. So those are two big things about the constructor. Doesn't return anything, shares the same name as the class. So when you construct your bank account over here, I pass in two initial values, and then the constructor will finish constructing the object based on those values.
So when you call a class by name, its constructor.
Call a class by name. So you have to use the new. You can't just do bank account, because it's going to ask, well, where's the bank account function inside the bank account tester? So you can't just call the constructor.
Right.
That doesn't happen. In order to call the constructor, you have to actually do a new, which means you're going to create an object. And we're going to talk about memory if we get to it today. And then you're going to say new, and then which constructor am I calling? I'm calling the bank account constructor that takes two integers. Well, we'll say a double and an integer. Go over here, double, integer. It calls that function after it's initially constructed the object. Because Java's going to first create the object, allocate the memory for everything, and then call your constructor,
Okay.
which should initialize your values. Okay? All right. So what's the interface? Did we ask this? No, I asked this, but we didn't get to it. What's the interface to this class? What's public?
Everything.
Except,
Oh, the balance and count.
right, so the balance and the account number. So if you're over here and you're testing it, you can just do John dot, and you realize you can deposit, you can get the account number, get the balance, and you can try and withdraw. Those are the only four things that you can really do. The rest of this is stuff that Java adds. We'll talk about that later. But the interface right now are just these four functions. Okay. Why do we code this way? Well, right now we're storing the value inside of Java. What if later on you decide you want to store the value in a text file? Or we'll go even further. What if you want to store the value inside of the database that resides on a different machine? How would you change this? What would change? How about that? The value is stored in a database. Are we going to be having private double imbalanced?
That's what the example was.
Oh, it was?
Database reader.
Oh, okay,
That's
great.
what it was.
What a great example. It read my mind. Well, we wouldn't be storing it here. We'd have, instead, we'd have some connection to the database that may look like, let's see, we'll just do MySQL reader. We'll call it MDB reader. And then you could try and set up initial and balance, which would try and contact the database reader. When you try and deposit, you'll go contact the database and try and add the money, and it would tell you whether it was able to do that because it's over a network. That's why we return Boolean here, in case we needed to. Withdraw, it would go query the database, hey, can you do this? If so, do it. And then return if that was successful. Get the balance, ask the database reader, what's my balance? Get the account number, again, grab that from the database reader. So here's the important question. Did the interface change? So the interface stayed the same, but the way it worked changed in the background. That way, anyone who wrote code that adhered to the interface doesn't have to change their code just because we now interact with the database instead of locally with Java's memory. Is that clear? That's a very key important concept in OOP because we divided the interface to the implementation thoroughly. So since they are disjoint, if you need to change the implementation, you don't have to change everyone else's code. You just change what's contained inside this one class. Any questions? All right. I'll go through the slides, make sure I captured everything. So reusable classes tend to have interfaces that are more abstract than concrete. In this example, deposit and withdraw is a little more abstract than, hey, let's go talk to the database, get the information back. That's concretely what's happening. So it's a little more abstract. Abstract interface is more general. Again, you're just depositing, withdrawing, not trying to contact an interface, database. Minimal user interface. I think that was a great example with transfer. Because since we have deposit and withdraw, we don't have to also add transfer, although we could, which might be helpful. We don't have to add it because you can do those with just deposit and withdrawal. Although if we added a transfer function capabilities, we would just reuse our deposit and withdrawal, and we wouldn't have to change that either. So that's a great example of what do we call it? Providing the minimal user interface.
I have a question.
Yes.
So if, say for the bank account there was a checking and saving, would you have to include that with inside of your withdrawal and deposit?
Okay. So what we would do, this was a very simple bank account. We'd probably also have to include the bank account type. And then when you do your deposit and withdrawal, maybe you do something checking the type as well. And that way it would be extended to that. When we go to inheritance, this will be even a better example of why inheritance is so useful. But that's a great question, and we'll actually do a little bit more later. All right, determining the users. Who are the users? Your impulse is to say it's customers. That's only half right, because your developers are also the users. What's key to realize when doing OOP is other programmers are using your code, so they are also the users, not just the customer, aka the end person who has no idea what coding is. So keep that in mind. You're trying to help other programmers use your code easily while you're still hiding all the implementation in case you need to change that later. Users have unrealistic expectations. Yeah. Developers they want to be able to do whatever to your code. So this public-private or encapsulation is a way to enforce what's allowed and what's not allowed. All right, behavior. Your behavior is the methods. Again, the behavior of this is your interface. It's a bank account. You can deposit, you can withdraw, you can check the balance, and then get the account number. So that's how the object behaves. All right, this is going a little beyond this. Well, Yeah, this pertains. At some point, your hardware might limit what your software can do. You may not be connected to a network, but you might need to use a specific type of printer. Just something to keep in mind when designing. So yeah, when discovering or declaring your public interfaces, which notice that when I created the bank account, the first thing I did was write out the public interface before I did any of the implementation. That's usually the best place to start. When you write your code, just stub out what you want your public interface to be or what you believe it should be, and that's a great way to begin. And that stub out is what I did at the beginning, where I just wrote the function heading and just gave a default return value. So that's stubbing out. That's a great way to start. But do keep in mind that your public interface will change over time because it's iterative. You'll think one thing is great, and you'll realize, oh wait, I need to improve upon this. That's normal. All right, with the implementation, this time around, I'm going to try and, while the implementation is very important, I'm going to try and reuse much of the Java library as possible. In previous sections, we would go into data structures about how all your data was laid out, trying to decide which structure to use. But this time, I'm going to really focus on just using the Java library to get it done, because I want to make sure we focus on how OOP works. But there is a section right after you have your public interface to decide how you should implement that public interface. And you will still need to make those decisions, but you'll have a lot of library help. Okay, great. So that was chapter 2. Any questions? No questions? All right. How are we doing on time? Okay, good.